Okay. What did you guys get? Yes.
4 times y to the fourth or x squared.
Good. That is correct. So when you multiply fractions, you guys know that you just go straight across, multiply all the guys on top, multiply all the guys on the bottom. You want to do it up here? Let's go for it? No? Okay. Alright, so if I look at what we have in common here, now one quick one here is you guys have these leading zeros. Just go ahead and knock them out. Because what I'm technically doing is I'm dividing top and bottom by 10. Right? 120 divided by 10 is 12. 80 divided by 10 is 8. You're allowed to multiply or divide the top and the bottom of a fraction by the same value, and you'll have an equivalent fraction. Alright, so okay, anything else that I want to see in common? I see an x and an x. Divided by x becomes a 1. Divided by x becomes a 1. 2 and 16. Divided by 2 becomes a 1. Divided by 2 becomes an 8. 3 and 9. Divided by 3 becomes a 3. Divided by 3 becomes a 1. 12 and 8. Divided by 4 becomes a 3. Divided by 4 becomes a 2. I have 3 and 3 now. Divided by 3 becomes a 1. Divided by 3 becomes a 1. 2 and 8. Divided by 2 becomes a 4. Divided by 2 becomes a 1. Y to the fifth and a y. Divided by y becomes a 1. Divided by y becomes a y to the fourth. Y to the fourth. Right? Because y to the fifth divided by y is y to the fourth. Right? Just subtracting the exponent. And then now I have something that's a lot more simple than what I started with. Now I can go straight across. 1 times 1 times 4 times y to the fourth times 1 is just 4y to the fourth. And then the bottom, 1 times x squared times 1 times 1 times 1 times 1 is just x squared. So this is the principle that you need to make sure is good. Go ahead and start recording again. Does anyone remember why radians are maybe better than degrees? What they allow us to do that degrees cannot let us do? It gives us something that degrees can't. You said a line?
Length.
Oh, length, yes. Length of what? The arc. But you got it, yeah. So that's one advantage was that there is that they give us radians give arc length. Degrees cannot. And that's why when we use that formula, this formula here, theta, which is the central angle measure, has to be in radians. So just a quick review over this. When you guys first learned about radians, you didn't know you learned about radians. They just teach you the circumference of the circle is 2 pi r. Well, this 2 pi, this is 2 pi radians times the length of the radius. And so I went ahead and color coded, okay, this r is this r here, and what's in red here is what's in red here. So now I'm just kind of solidifying something that you were taught, but you weren't taught as radians. So one full rotation, a full circle, is 2 pi radians. And that's why we said this. Because we know 360 degrees, right? So 2 pi radians is 360 degrees. That's all we have here. This is the formula we use to find any arc length as long as we have the measure of the central angle. If it's not in radians, convert it to radians, and then the length of the radius. I think we completed this one. Yeah. So a quick review. This was given red. we had the angle was given, we had the radius of 50 feet, and we wanted to find this arc length, because we have this, just this one sector of the circle, it's part of the circle, so this is part of the circle. So we convert 45 degrees into radians, plug that into our theta, and r is of course 50 feet, and we get 25 halves pi feet, which is approximately 39.27 meters. Any questions on this? This is just from yesterday.
Oh, no, that was really easy for me yesterday.
Okay.
I was doing it yesterday.
Let's see. Okay. Did you guys, where did we leave off? Did you guys do this one? You tried that one?
And then
you gave us what, remember,
you
at the
gave
last
us-
minute?
that I don't
Right.
give us the number.
Yeah, okay, so we got this one. Okay, awesome. So this one, you can see, again, the only thing here is just make sure you know which one to use. You don't want radians squared over degrees. That makes no sense. You want, so the radians cancel to one and one. You're left with degrees. And this is kind of like the warm-up. I mean, you can simplify stuff diagonally, or you can just go straight across like this and get the same value. Anyone more time on this? Okay. So,
Wait, she had a question.
what's that?
I was going to say, on those like little doing things diagonally, do we have to put all the ones and stuff? Because that kind of confuses me.
Nope. The only thing is just know that it doesn't go to 0. I think for some reason I've heard students say, "Oh, it goes to 0," and that's not the case. It goes to 1 because you're doing division. Okay. All right. So this is the problem that we kind of left off on. Go ahead and try this.
That's a 7, right? 7.
Yes. Yes. 7 pi over 3 radians. Can I try to keep your head up, please? Thank you. Yes.
That also false information in both.
Yep. So if you have the text and you want to follow along, we're talking about chapter 5.1, and this is drawing angles in standard position is on page 487.
487.
Yep. You
This
get.
is like the beginning, like this is the whole difference.
Yeah, this is talking about how to like draw an angle in standard position. So we'll look at piece by piece. So first off, I drew the one that's blue.
Wait, what's given?
Oh, nothing's really, this isn't really a problem. It's kind of just teaching kind of new material here. So this is how to draw an angle in standard position.
Is this, what is this? Is this 1, 2?
Trig, which is a branch of geometry. So we know that a full rotation is how many radians?
2 times 5.
2 pi. Very different. 2 pi is about over 3 times larger than 2. 2 pi radians is one full rotation. So 0 pi, like 0 degrees, if, you know, it didn't open up at all. 0 degrees is 0 pi. If you do one full rotation, the terminal ray would end up in the same position. So we're talking about initial and terminal sides. Okay, so the initial side, or I'll say ray too, because we're making an angle. The initial ray, or initial side, always starts here. We always draw it like this. Then it's a matter of if it's a positive angle, we go up like this. If it's a negative angle, we go down like this, go clockwise. even if you're not getting it right this moment, it's good to have the notes and later you can look at it. Okay, so we know a 90-degree angle, right? 180, 270, 360. And all I'm showing here is that you can keep going around. So a 0-degree angle is the same thing as basically a 360-degree angle. They end up, the terminal ray or terminal side ends up laying in the same spot. Okay? So the wording we use here, we're talking about coterminal. Coterminal, where they have the same, coterminal angles have the same initial side and the same terminal side. So notice 0 degrees was like this. If I went all the way around, notice the initial and the terminal both are at the same spot. So 0, 360, 720, these are all coterminal angles. Because the initial ray and the terminal ray are in the same place. And we'll talk more about coterminal angles in a second. What I want you guys to get is just like the map, okay? Y-axis is called graphing the standard position. Here's a 45-degree angle. If 2 pi is 1 full rotation, then how many radians is half a rotation? 1 pi, which we more commonly know as, of course, 180 degrees. And then notice again, we have 0, 2 pi, 4 pi, 6 pi, just another full rotation, you end up in the same spot. So these are all the same. These are all coterminal to one another. 0 pi, 2 pi, 4 pi. And over here we had half rotation was pi. So if we wanted to do an iteration of this or a repeat of it, for another full rotation, well, pi plus 2 pi is 3 pi, plus another 2 pi is 5 pi, and so forth. So these are all coterminal angles. So now you start, basically the main point of this section is so that you're not uncomfortable with radians. It's trying to get you more comfortable with radians. So start to get, when you hear 1/2 pi radians, you know they're talking about a right angle. They're talking about what you know as a 90-degree angle. When they say an angle that's pi radians, they're talking about a straight line or a straight angle, which is 180 degrees. Yeah.
Is it 360 degrees go with 2 pi?
Yeah, 360 degrees is 2 pi. Yeah, if you want to do it like that, yeah. So yeah, I didn't really necessarily line these up perfectly.
Is that 3 pi over 2?
What's that?
That's the 273 pi over 2.
Yep. So 1/2 pi, 1 pi, 1.5 pi radians, and then 2 pi radians. Yes. Yes, ma'am. So therefore, if 90 degrees or right angle is pi over 2 radians, 45 degrees makes perfect sense would be 1/2 of a 1/2 pi radian, which is a 1/4 pi radian. So 45 degrees is 1/4 pi radian. And negative 45 degrees is negative pi over 4 radians.
So half of the 90 is half of pi degree. Half of pi over 2 degrees.
1/2 of pi over 2 radians.
Radians.
Yeah. Any questions about this? Yes.
Okay, what I don't get is what I don't get is the, like, so this is not actually a problem. So what is this? This is just us, like, more understanding rationals. Correct?
Rationals?
Or whatever, radians.
Yeah, well, radians is the measure of a central angle. It's just showing you specifically how to, graph how to put an angle in standard position. Yeah.
Didn't you say they have several over there, whatever it's called, it's for arc one? Is that 0 of them?
No, theta is the measure of the central angle. But it can give you arc length by taking it and plugging it in that formula. By taking the measure in radians and plugging it into that formula, where S is equal to theta times the radius, to get arc length.
So in this, that means the metric central angle.
Yeah, theta is just the measure of the central angle. So theta is negative 45 degrees. Theta is negative pi over 4 radians.
The central angle is one that cuts the line in half.
No, the central angle is just the angle, the angle. Okay, all right, so coterminal angles, two angles with the same initial and terminal sides. We just saw a lot of examples where 0 degrees was coterminal with 360, which is coterminal with 720, etc. Two angles with the same initial and terminal sides. If you're following along, this is around page 490 now, example 5. So, you had, say you had 420 degrees. What could be, and specifically in this example, they say, okay, assume the following angles are in standard position. Find a positive angle less than 360 degrees that is coterminal with this angle, 420 degrees. These are two different examples. So again, a coterminal angle of an angle coterminal with 420 degree angle that's less than 360. Okay? So there's two ways to think about it. You can think about it like, okay, if I went back to here, a 420 degree angle would end up where? Go all the way 360.
Yeah, what do you mean? I know.
160, right? Wasn't
Wait, where
it?
does it start?
Wasn't it?
It's 420.
420. We go all around 360 plus 60 more. Plus 60 more. So it'd be 60 degrees.
Yeah. Would it be?
Would it?
Yeah.
Yeah, it is, yeah.
Okay.
Wait, no, I was like, wait. Yeah,
And by saying that, you've answered the question. 60 degree angle.
how do you answer the question?
Because if I do 420 degrees, that's going all the way around 360 plus another 60, and it said give a coterminal angle that is that's positive but less than 360 degrees. Well, we go 360 plus another 60, and in there, and you in there, and that's the same thing as just saying a 60 degree angle would have they have the same initial and terminal sides. So that's one way to think about it. Another way to think about it is because you know that there's full revolutions are every 360 degrees. You just take 420, subtract 360, and end up there.
Would 360 be given, or would you have to like, how would you know?
You were just given 420 degree angle, and it says find an angle find a coterminal angle to that angle that's less than 360, but you know it's positive. So we just took 420 and subtract 360, and you get a 60 degree angle, which would be coterminal. Because they would end on the same. Their initial starts, and then their terminal ends on the same. Yes.
Okay. You said the initial angle is the one that's like the beginning one.
The initial side.
Initial
is
side.
this ray here.
Okay.
I could say initial ray too.
The other one, you said the terminal?
Yeah, the terminal, like for example, this blue example 45, this is the terminal side, this is the initial side.
You said that coterminal has, there will be initial and the terminal both end up at the same place,
Yep,
right?
yep.
But with the 420 one, then if you add 60 more, then it doesn't. Okay, wait. I'm confused.
Okay, so this guy doesn't move. Then you take the other ray you need to make your angle, your terminal,
Okay.
and for 420 you have to go all the way around plus another 60 degrees.
But then the terminal ray would end up up there, not with the initial ray.
But we're saying that the 60 degree would be the coterminal angle.
Oh.
Yes. Yes. All right. And then now, try this one. Try a coterminal angle to negative 120 that's positive but less than 360. And there's two ways to think about it. You can think about it like, okay, if my terminal side, I'm going this way because it's negative, where would it land? And wherever it lands, that's what you got to do for, if you went the other direction, it would need to land there too. And whatever angle that is, that's the coterminal angle. Or you can just think about it, if you know that it repeats, there's an iteration, every 360 degrees, you can just add 360 to negative 120 and be done. And I'll show you.
Wait.
So what did you get? Did you get it?
That's what I'm saying.
You could subtract. Not negative, it's got to be positive though. It's got to be positive, but less than 360.
I don't know. You said that we could subtract. You know, like what the 420, you said we could subtract 420 from 360. And we got 360.
No. If we subtract 360 from 420, you get 60.
If it goes the other way, I don't think there is a way it could be not negative.
Well, we'll see. Someone said, you say 240?
Yeah.
240 is correct. So let's talk about why this one's 240. So don't let the negative throw you off. If you think about this, okay, negative 120, so negative 120 would end up somewhere over here. Okay? Think about if you went this way instead, as long as it lands in the same terminal side, that's a coterminal angle. So what would that be? Well, think about just the absolute value. So 120 this way is the same thing as 240 this way, because 240 and 120 make 360. You can think of it like that, or just think about it like this. If you go to negative 120, and then you add 360, you'd also end up the same terminal. Good. So you can think of it either way. But honestly, the easiest way to just do it would be to just subtract or add 360, or however many multiples of 360 it would take to get what they want. And they wanted a coterminal angle that's positive, but less than 360.
Okay. Okay.
When you're doing something and it ends up working out algebraically to where there's more than one solution, because if you keep doing it, where they say x is defined between these intervals, you keep going, it sounds like totally out there, or you're just talking about it. But you will eventually have to deal with it where you just keep going until, okay, I know this is not part of my solution because I'm too large. Good question. So this one we had a little, this was the class where we had the fire drill. So I ended up not assigning homework for the weekend for that period. But do you guys want homework?
No.
I had not.
I'm just saying that I want to try to be a bad
When you come back?
So does anyone have any questions about anything? You want to see a problem worked out on the board? You want to see another example? Yes? Yes. Yeah. Yep. Adding 360 subtracting 60 degrees will end up at the same place. Now, if they give it to you in radians, you can add or subtract any multiple of 2 pi radians. Why are you standing? I'm tired. You're standing because you're tired. Please sit down and breathe.
So with the negative numbers, would you would always, wait, that one you subtract it from 360? Wait, go back to another 360? Okay, and
You would either add or subtract 360.
does it matter if it's a negative 500?
It depends on what the directions are saying. Like for these directions, they wanted a coterminal angle that was positive but less than 360. So that direction can tell you kind of what to do. But if you got a situation